when using the law of sines and cosines, sometimes it gets a little bit confusing on which one to use when we're given any triangle. But before we even use these laws, we should know how to solve right triangles. And the two tools that we're given for that are SOHCAHTOA and the Pythagorean theorem. And let's solve for this blue x angle right here. We would use SOHCAHTOA for it, and that basically says that x is equal to the tangent of the opposite over the adjacent. So this would be the opposite, and then this would be the adjacent side. And then we get that x is equal to tangent of 7 over 13. And then we just plug that into our calculators and we get an answer. And then to find y, we would use the Pythagorean theorem. So we'd say that 7 squared plus 13 squared is equal to y squared, and then we square root both sides. So that's how we get to this answer right here. But what happens when we don't know if it's a right triangle? For example, let's say this problem right here. We don't actually know if there's a right triangle, and by the looks of it, it doesn't look like there is one. So we can't use SOHCAHTOA or Pythagorean theorem because they only apply to right triangles. So in this case, we would actually use the law of sines. And that's what this video will mainly be about. So here we have the law of sines, and it says that the sine of an angle A over its opposite side is equal to the sine of B over its opposite side, which is equal to the sine of C over its opposite side. So we can say in this problem here that the sine of 76 over 11, which is the sine of A over A, is equal to the sine of C over 6. And so that's what we kind of wrote here, and that would be just this part of the law of sines. So sine A over A is equal to sine C over C. And then once we solve for what we need to kind of make our equation, we can multiply both sides by 6. So we get sine C is equal to 6 times sine of 76 degrees over 11. And then the way that we get rid of this sine on the left side is we take the inverse sine of both sides, which we can do on our calculator. And that will essentially get rid of the sine here and then add an inverse sine on the right side. So we get that C is equal to inverse sine of 6 times sine 76 over 11. And when you plug that into your calculator, you'll get that C should be around 31.95494 degrees. So measure of angle C is roughly equal to that. And that'll be a good enough answer for that. But let's look at the second problem here. Can we do the same thing? Let's see. Okay, so we can see here we have the sine of f because we have the measure of that, and then we can make it over 7. So we will write that kind of sine of f over f is equal to, and then we do have 8, but we don't actually have x, and we can't use this angle D here because we don't know it, so we can't really solve for x right away. And so what we can do is find angle E. Oh, that's a bad line. Angle E, and then we can use the fact that all the angles in a triangle add to 180 to find angle D, and then use the law of sines again to find x. And let's do that plan. So sine of f over f is equal to sine of E over E. And when we plug in the values that we know for that, we get that sine of 37 degrees over 7 is equal to sine of E over 8. And then we multiply both sides by 8, and then we take the sine inverse of that. And so we would get that E is roughly around 43.45531 degrees. And once we know that, we can use the fact that all the angles in a triangle add up to 180. And so here we do that. Measure of angle D plus measure of angle E plus measure of angle F is equal to 180. And then we solve for measure of angle D because that's what we need to solve for x. And so when we solve for that, we get that measure of angle D is around 99.54-ish. And now that we know that, we can actually use the law of sines again. And since we know that the law of sines basically uses one angle and then its opposite side, and then another angle and its opposite side, this angle D here is paired with this opposite side. And we know sine of f, and we know what f is, so we do sine of 37 degrees over 7 is equal to sine of D over x, and x is what we're trying to solve for. And then we cross multiply, so we get that x times sine 37 degrees is equal to 7 times sine of what we found before to be the measure of angle D, which is 99.54469. And then we divide both sides by sine of 37 degrees to finally get what the answer for x is. And then when we do that on our calculators, we get that x is roughly around 11.47046. And that's the length of side x. And so this is how we would use the law of sines. And in the next part, I'm going to kind of go over how we would use the law of cosines to solve for triangles where we don't know if it's a right triangle, or we just straight up know it's not a right triangle. And we have to kind of solve for angles or solve for sides in that triangle.